Well, thank you everybody for joining us today. My name is Meredith Hassett and I am a developer advocate from the Velo team. I normally am based in San Francisco, but as you can see, I'm in an office. So I'm actually in New York City today. So I do apologize if there's some background noise. There are actually people in this office, unlike the San Francisco office. So apologies in advance if there's any background noise. And today we have with us Ofir, and he's going to be showing us some behind the scenes of Velo and show us how our backend code runs. And with that, Ofir, you want to go ahead and introduce yourself and start sharing your slides?
Sure. Hi, everybody. Super excited to be here. Okay, let's dive straight into it. So today we're going to talk about running Velo backend code, and we'll look inside behind the scenes and what happens when someone writes a backend Velo code. So first of all, thank you for coming. I know that you're logging in. It can be evening, morning, early morning, night. I don't know where you are. So thanks a lot for coming and joining. And I hope this will be interesting and beneficial for you. I'm also, like Meredith said, really glad to see you here and talk to you later if it's possible. We always like to meet our users. So hi, oops. Okay, so this is from the template. Let me see if I can fix it real quick. Okay, this is better. Hi, I'm Ofir. Most of my time is I'm spending writing decks and spreadsheets. I'm also a big fan of side projects. I'm not a bar musician, but I am bar dependent. And believe it or not, I am a princess daughter tutor. Namely, the princess is my sister, and I tutor her daughter math. And also, I'm the Velo R&D manager, so I'm really glad. I really like this job, and I think the Velo product is awesome. And I hope you all agree. You all agree.
Who's the pup, Ofir?
So, the pup is her name is Minnie.
Minnie.
Yeah, she's pretty old. She's not a pup, but she's cute. Okay. On the agenda today, first we'll have a short terminology, so we'll be all aligned on all the terms that we use in the backend when writing Velo. We're gonna talk about, like we said, about running a backend function or a scheduled job. We'll see the backend runtime container lifecycle. I hope it will make sense soon enough. We'll talk about the limitations of the Velo platform, and we will try to do a live demo. No promises there, but we'll try. Okay, so we'll start with the terminology. First, okay, it says that a participant can see my screen. I hope you could see it before. Okay.
Yep, we're able to see.
First, when we talk about when we say user code, I mean when I say we is let's talk about, for this talk and this talk only, we will only talk about the backend. So we're talking about, when we say user code, we mean everything under the backend folder. You can see it on the right. Okay, so all of your JSW files, the jobs configuration for scheduled jobs, the events, HTTP functions, all of these files, this is when we're in the context of backend, we call it user code. We also have something that we call the Velo runtime. What is the Velo runtime? The Velo runtime is a Node.js server that is capable of serving the Wix site's backend request. The Velo runtime is responsible for exposing REST endpoints. For example, if you write something into HTTP functions, the JSWs are also REST endpoints or HTTP endpoints. It looks like you call from the client to a simple method, but behind the scenes, it sends the request to the server. It's responsible for running your code to give you access to the NPM packages that you install, to the Wix APIs as well. monitoring, logging, and everything else. Another important word is Docker containers. Basically, this is not related to Velo at all. It's a technology that is very common in today's world. It allows you to package and run any software, and it comes with all of its dependencies. So before we had Dockers, we had only code, and we wanted to, let's say we have a server code that we want to run, and we want to run it on 10 different computers. And we had problems such as one computer comes with an OS configured to a specific version, and it has a specific node version, and it has all kinds of like dependencies that could mismatch. And out of a 10 servers, maybe 9 would be up, maybe 8. And Docker just did a revolution in that area, because you can think about it like as you see on the right, like it did a revolution in the naval industry, the containers. Docker did kind of the same thing. You pack your code, you tell it all of your dependencies, and that's it. You can run it anywhere that Docker runs, which is pretty amazing. You don't need to think about it that much. So when we also, I'm going back to the Velo runtime, we also call what you see here the container. So this is exactly like the Node.js server runs inside the Docker container. Okay. Next is cold start. What is cold start? Cold start is the time that takes to start up a new resource where there are no warm up resources that can serve a request. Basically, if we have a server, we measure the time that it takes for the server to load. It can depends on the server state. Sometimes you need to install its dependencies. Sometimes you need to do a lot of initialization processes in the before you can actually serve a request. So this is what we call cold start. Sorry, I'll close the window. Might be quieter. Okay. Before we start, a short disclaimer. What you're gonna see here, it's a simplified model. Okay, reality is much more complex, but it helps you to create a valid mental model. Okay, this is basically the important things that you need to know when you think about how Velo platform behaves and operates. So let's start. It's a little bit slow. Okay. So first of all, as we know, we write backend, so we need a server to serve our requests. And we have two naive solutions to do that. The first one is, what's the problem? We'll just create a dedicated container per site. You write code, you publish. We start a server for you, and that will be your server for all times. As you can see on the right, down right, it's gonna create lots of containers, which is not really super effective for us, because we won't be able to scale. We won't be able to serve all of the requests. You know, Wix has lots of sites, and it will be very costly to do that. We have another option, which is to spawn a container for a site upon request. So let's say I have my site.com, and the first time, or any time basically, that someone goes to my site and it needs the server, I will spawn a container. This is also problematic because installing a server with all of its dependencies and running it will take time. It can take up to sometimes even 10 seconds, maybe even more, which is not really a good experience for the users, right? So Velo, in Velo, we came with a better solution, we think. And what we did is a little bit of sophistication, a little bit of both. So first of all, we have a pool of ready-to-go machines. When I say ready-to-go, I mean that they have all of its dependencies and all of the NPM packages that you might want to install or you installed. All of the Wix APIs already warmed up, the server is up and running. It has everything it needs except for the user code, because the user code is basically the part that is dynamic, that is unique for each site. So that's what we do. We have a pool of these. Upon a first request, we load only the user code. The user code usually is very, very small, like a few kilobytes, maybe less than a kilobyte even. And then we serve the request. Let's have a deeper look. So a basic flow of a first request. We have a request on the right. Okay, we go into a phase we call discovery. We need to find out whether there is a server running for this site or not. Sorry for the delay, the presentation has a huge lag. Okay, we see we don't have a resource for it. We allocate a new resource and we serve the request. Easy enough. We also want to register this server, because next time we can actually make it even faster. Okay. Moving on. So let's have an even deeper look. So remember the pool that I told you about of all of the servers running. So this is the pool of warmed up servers. We take one from the pool. We deploy the user code. So we actually only take the user code. Everything else is ready to go. We mount it on while it's running into the server. We register. Okay, so site A is mapped to container number ABC123, and site B is mapped to container CDE456. And then when there's an incoming request, we serve the traffic. Okay. Now let's look at the second request. Oh, okay, sorry. So the second request, we go into this database, which is super, super quick. It has a map, like I said, between the site and the container ID. And once we get it, we send the traffic straight to the container. Okay, so I'll ask a few questions and I will answer them as well. So the first question that comes to mind is like, what is my site container capable of serving? Is it a specific function? Is it the whole site? So the answer to that is the whole site. Okay, so each whenever I load a specific site into a container, all of the requests for that site will go into this container. Question number 2 is like, which user gets a cold start on their container? So that's a really good question. It has a rather complex answer, but it's not that complex now that we know how it works. So basically, which user is the answer is the first user that requests something from a site that doesn't have a running container. And we will talk later on which sites has live running containers and which not. Question number 3 is, am I sharing a container with other sites at any point? The answer to that is strictly no, because we care a lot about security and each container has a total isolation, and except for the shared resources such as the npm packages and the Wix APIs code, you don't share anything. Not shared memory, nothing. Another question is, what is the boundary of a container? Is it allocated per site viewer, per data center? So to explain that, I will talk a little bit about what is a data center. Data center is basically a place, like a farm of a lots of physical machines. You might have heard about AWS or Google Azure. So basically, these are places like huge warehouse with a lot of physical computers. And the reason we have a couple of, like a bunch of data centers is that we want to have the quickest response time for any request. So if you're sitting in Europe, it will be quicker for you if your server will run in Europe. And if you're sitting on the West Coast, you want a server that is close to you in the West Coast and on the East Coast and in Asia and everywhere else in the world. So the answer to that is depends on where your user coming from. We are spread all over the world. So the first request from Europe, you will get a container in Europe. And the first request in West Coast, you will get a container in the West Coast. So in any given moment in time, you can have a few containers of your site running on different data centers. Okay, so an interesting question is, what is Velo cold start? So I said earlier that the cold start of a regular server, if you need to install its dependencies and all of the npm packages, it can take up to, let's say, 10 seconds. What do you think the cold start for Velo, for our hybrid solution? Yeah, I will tell you, it's between 40 and 80 milliseconds. Okay, so we have 1,000 milliseconds in 1 second. It takes 40 to 80 milliseconds. It's really quick because, again, all we do is take the user code and load it into the already running server. This is what makes it super fast, and it enables Wix to provide the Velo platform for free. Let's talk about running a scheduled job. It will actually be very quick because it's almost identical to running a backend request. So we have the task dispatcher. It realizes that it needs to run a task now. It goes to the registry, checks if a site is up. If yes, it proxy the request. It sends the request to the container. If not, it does the same mechanism of allocating and then registering and then serving the request. So it's exactly like a regular request. Question that pops to mind: does a scheduled job run in a different container from all of the rest of the pull request? The answer is no. It's the same registry. It doesn't matter if a user sent a request or a scheduled job. Okay, so we talked about the containers and what is their role, but let's talk a little bit about their life cycle. So we said that we have a pool of containers, right? And then someone asks for a request, we allocate. We say, okay, this container, you belong now to site A. Now what? Will it be on forever? Not forever? So let's talk about it. So we have the pool, we know that. We allocate. Once we allocate, we lock the container and we change its status from pool to running. Once it's running, we start a timer of 5 minutes. After this timer is up, we change again the status of the container, and we say, and we change it to stopped. Then we wait for another 1 minute, and we actually terminating and deleting the container. So let's go over it again. We have the pool of non-assigned servers. We allocate. Now it's locked. Only this container we will serve only one site, and it will do it for 5 minutes. Why 5 minutes? Just because. I mean, it's not just because we analyze the data of, you know, when user has traffic, because our cold start is so quick. It doesn't really matter. Like the second request will only be quicker in 40 milliseconds. It's not that much. So after 5 minutes, usually when a site has traffic, it has traffic for a few visitors or a lot of visitors. It doesn't really matter. And then there can be peaks of visitors. So for us right now, it's very convenient to run the server for 5 minutes, and then we terminate it, but we give it 1 minute grace. What happened? Okay, so let's talk about stopped. Once a container is flagged as stopped, the next request that will come to the same site will allocate a new container. So you have situations where you have two servers running at the same time, and it's fine because all of it can basically, it's called horizontal scaling. You can basically have lots of servers serving your users. And once it's stopped, we give it 1 minute grace to serve all of the current jobs that runs on the server that hasn't finished yet. And only after that minute, we terminate it and return the container to the pool. Okay. Question, for how much time, maximum and minimum, do I get my container? So the answer to that is 5 minutes. It's the minimum and it's the maximum. It's pretty just the way it is. But it doesn't really matter. As I mentioned, the cold start is so fast that the user doesn't really notice whether he's the first request or the second request. Okay, I want to talk about limitations because there are a few limitations which are important to know. And okay, first is request per minute. For free sites, we have 5,000, and for premium sites, we have 7,000. If you need more, if you have more traffic than that, please talk to us and we will see what we can do. Request timeout. So every request to our servers has a 14 seconds timeout. This is a limitation. Usually it's pretty standard in the industry for HTTP requests to timeout. I think the maximum is 30 seconds and we give 40 seconds. Basically, if you have something that needs to wait more than, I don't know, like 3-4 seconds, I suggest you change the way it works, because the user, for a given user to wait 14 seconds, it's way too much to get an answer for something. CPU, so it has in AWS units, it has the CPU unit. So each container has a 0.7 CPU unit. Okay, it has 800 megabytes of memory. And the container uptime, like we said, it's 5 minutes and then 1 minute grace. So if you got a request on the 4.59 seconds, you can be sure that that the request will finish properly, because the server will only die a minute later. And as we said, we already have the 14 seconds limitation, so it doesn't really matter. We took a buffer. And if you want to learn more about the Velo limitations, you can Google Velo limitations.
Cool. This has been super interesting. We do have some questions that came in through the Q&A, and I'm learning a lot about how we run our backend code too. So I don't have the answer to these. So I'm going to go ahead.
Do you see my screen?
Yes.
Okay. Yes.
Yeah. Okay. So one of the first questions we had is, does backend code run differently than public code, or does the same apply to your public code as well?
Public code is available from both the server and the client. So the difference between a file that exists under the backend folder is you will never have an access to on the client side. It won't be available on the client side. And with public, it will be mounted both places, also on the client and also on the server.
The next question we have is around performance. So when you have multiple JS files in your backend, does it make sense to have a bigger module or break them into smaller modules that are importing each other?
For performance purposes, I would say it doesn't really matter. But for clean code and best practices, you should.
Do the smaller modules, yeah.
Yeah.
Cool. And then the last question I have is around the real-time API. Does it live through container lifecycle? How does a downtime between container lifecycle affect it? For instance, if a user loads a page and waits more than 6 minutes for a message.
So real-time API is really, really interesting topic. It's a really interesting question. Basically, real-time API based on a service that runs 24/7, and it runs outside of the container. And whenever we either send a message to the container or from the container into our client, it's just passing through the container of our code, and it goes into the Wix, let's call it the Wix service of real-time. So there, it runs 24/7. It's up and running all the time. And the real-time service, the Wix service, knows where to dispatch it. Okay, it knows where the current container for the site, so it will know to send a message to it, and it will send it to its client.
Okay, that's really interesting.
I hope it's clear.
Yeah, that's really interesting. I think definitely real-time is one of those APIs that we want to definitely do another deep dive into. So something that we'll put on our radar, because we get a lot of questions about real-time and like more complex examples of it. So I think that'd be really cool to dive into in another session. Okay, next question we have: how many concurrent requests are supported in the Velo platform?
That's a good question. It depends on what your request is doing. If you will try to kill your server, like do a very heavy computation, it depends. The limitations, as I said, the server has 800 megabytes of memory, and it has 0.7 CPU units. So if you'll try to compute the next unknown prime number, probably you're gonna crash it. But so the answer is it depends on what you're doing. If you're doing a very simple thing, you can have lots of concurrent requests. And if you're doing a very hard on the CPU or very memory consuming, then up to the limitations.
Got it. Makes sense. Let me see. We had one question that came in earlier too. Are there loading time limits for custom elements files or NPM packages? Does that 14-second timeout apply to those as well?
Applies to the NPM packages?
Yeah, NPM and or custom elements.
The custom elements, as far as I know, are only supported in the client. So it's just client code. It doesn't relates to the container that runs the user code, the backend user code. As for NPM packages, as I said, we don't measure it. That's how we get the cold start to be so quick, because basically what we have think about like a directory that has all of the NPM packages ever. And what we do in the pool, like of the warm servers, they link to this folder. So it's like they have it on their machine. It's not really exist on their machine, but it has a link. So it's mounted on top, and the server thinks it's just another directory. And you can actually see it when I logged into the machine. You could see the npm folder as if it was always there. So it's not related to the 14. The 14 seconds is for a request. If you will have a request and you won't send back a response to the client in 14 seconds, we will kill this request and we will say this request timed out.
Okay. Cool. How much memory is taken up by Wix packages / APIs?
Nothing. It's just code. So basically, the memory goes on the Elementary itself, the Node.js server itself. And basically the 800 megabytes, almost all of them are reserved for the user.
Okay. Yeah, so like it doesn't matter how many packages from Wix you import in your backend functions, it won't affect your memory.
Like it matters a little bit because they are loaded into the memory, but it's just code. It's a few kilobytes. It won't get up to half a megabyte even.
Cool. Okay. I'm learning a lot from this too, so this is really interesting for me. Because it's like I know how to write the code, but I don't know how it's working on the back, like behind the scenes. Okay, next question. We keep getting more questions. Is it possible to get more resources for clients that are looking to build? Wow, I cannot read. Is it possible to get more resources for clients that are looking to build more complex and request-heavy websites? Is that what Wix for the enterprise solution is for?
Definitely. So we are building, and we already have a solution in place for very heavy traffic sites. So if that's the case for you, just contact us and we can set it up. It's not the default configuration, but it's totally, our system supports it. It's just a matter of configuration.
And I will also plug DevCon here too, because there might be something really interesting that we're talking about at DevCon about Wix Enterprise. So if you are attending either virtually or in person, definitely tune in to Yaniv Bakrat's keynote on day 2 in the morning. And he'll be talking about this more and talking about how you can get involved more if you want to start building some more complex projects as well. Cool. Okay, I'll leave it open for questions. These were some really good questions. I've learned a lot. I hope that you guys learned a lot as well too. It's really cool to see how we're doing this. And I know one of the things that we had looked at in the past was our cold start times versus like Lambda functions and stuff like that. And we actually one of like the fastest cold start times out there. So it's really cool to see how this is all, in obviously a simplified version, working for our users to get that quick cold start time. So does anyone have any more questions? Let's see if I missed anything in the chat. Is there a limit of the runtime of a scheduled job? Does that 14-second limit apply to scheduled jobs too?
Same, yeah. Good question, yeah.
We talked about the latency of warming up a cold server. Velo's is super low, 40 to 80 milliseconds. And yeah, any other questions? Again, the replay will be posted on the YouTube channel. So feel free to also ask questions in the Discord as well. We're super excited to have Ofir here, and we definitely want to find a way to have you come back and join us for like a round, like a in-person discussion too, whether it's virtual or actually in person at DevCon. super excited. Any last minute questions? Oh, okay. So we get an error sometimes saying request aborted. Could this be due to the 5-minute limitation? Or would that be the timeout?
So I would definitely want to check it. So if you have this happen frequently, so please contact us. But it shouldn't happen for the 5 minutes anyway, because like I said, we have 1 minute grace, and any request has a timeout of 14 seconds. So it's really hard to. I don't believe that's the reason. Maybe it's the timeout, but you should get a timeout error and not aborted.
Mm-hmm.
So I'm curious what happened.
All right, yeah.
Can we produce it? Please send it to me.
Yeah.
A deeper, more comprehensive answer.
All right. So Joseph, if you can pop that in our Discord channel and some more information about it, we'll take a look into that too, because it sounds like it might be related to something else.
Yeah, I'm also in the Discord. You can tag.
Yeah. Awesome. Well, yeah, as Ofir said, he's in the Discord. So if you have any more questions, or if you're watching the replay and something came up and you're like, I want to know a little bit more, feel free to ask that. Ofir, thank you so much for this behind the scenes look. I learned so much more about how Velo works. So interesting, super cool. Awesome to see that we're using like very standard technologies too, because I know a lot of people want to know like what is Velo running on. So super, super interesting. And thank you so much for being with us today.
Thank you for having me. Thank you, Meredith.
All right. Bye, guys.
Bye.